This tutorial will take you through some spline editing techniques. Splines may be connected in several ways. One way is to use the bridge command, which can be found in the Insert Curves from Curves menu. This command will create a new curve between a set of user-defined splines, curves, or edges. For this command, you must simply choose the two curves you wish to bridge and select whether you want the bridge to have tangent or curvature continuity at the points where it meets the selected curves. The endpoints nearest the pick point on each curve will then be connected by a single segment spline. If using the tangent continuity option, after selecting these curves, you also have the option to select a spline to control the shape of the connecting bridge. Another option is to use the slider bars to determine where along the path of the defining curves you'd like the bridge spline to begin. You can do this for each of the connecting curves by selecting the desired curve from the top of the dialog box. There are also slider bars in the dialog box which allow you to select how strongly each curve's tangency or curvature will affect the bridge curve. In addition, you may also specify whether you want the bridge curve to be associative or not. That is, whether or not the curve will be updated as you edit its defining curves. Be careful when using associativity, because any changes you make to your defining curves will affect the constructed bridge curve. You can also join connecting curves to create a single B-spline curve through the Join Curves option. This command is found in the Insert Curves from Curves menu as well. To use this command, you must first select two curves containing at least one common endpoint. Then, select your desired resulting curve type. General Spline may create a high-degree curve and thus introduce irregularities, and so one of the polynomial curve options is generally preferred. Note that discontinuities such as gaps and overlaps will cause an error message to display when attempting to join curves. If this is the case, a marker will be placed at the location of the discontinuity to enable easier editing. Once you've selected your curves, the input curves may be retained or blanked, which will not delete the curves but will turn off their display. If you don't choose the output spline to be associative, the input curves can then also be deleted or replaced. We will now look at some ways to edit spline parameters. Before we begin, a useful visualization tool can be found under the menus Edit, Curve, All. Here you can set the option to Display Original Spline. If this box is checked, the original spline will remain displayed during editing. You may also set this option when you first enter the Edit Curve Parameters command before you select the curve you want to edit. Both splines created through points and those created through poles can be edited from this command. There are several options available in the Edit Spline dialog box. The options for Change Slope, Change Curvature, and Change Degree all take you back to the dialogs used when the spline was originally created. You may choose Change Stiffness, which will also change the degree of the curve, but retain the original number of control poles. A higher number of degrees results in a stiffer curve. If the spline you are editing was created with the Through Points method, changing the degree or stiffness will delete the defining data points used to create the spline. Thus, new poles will be used to define the curve. Edit Point allows you to add, remove, or move defining points on the spline. Current points will appear as orange crosses on the spline. To move a point, you must first select the point, then either select a destination point or enter a delta offset, depending on which option you chose from the dialog box. You can also move a point by simply dragging it with the cursor rather than picking and releasing. In this case, you may also use the micro positioning option, which allows you to drag a point by 1/10 of the distance that the cursor moves on screen. Edit Pole allows you to add or move poles. Note that while you can delete points, you cannot delete poles. This is because the spline's defining data is stored in its poles. From here you can also change the slope and curvature at the spline's ends with the Match End Slope and Match End Curvature options. To use these options, you must simply click near the end of the spline you wish to change, then choose a point on a curve from which you wish to inherit the slope or curvature. As with editing points, you may either move a pole by choosing a destination point or delta offset, or by dragging on screen. Micro-positioning is also available, but can be refined so that the pole moves by 1/10,000th of the vector movement of the cursor. Micro-positioning is engaged by locking the icon next to it, or by dragging a pole while holding the Control button on your keyboard if you are in the unlocked mode. Here, the 2D curvature comb is also available, which allows you to graphically analyze the spline's curvature. The lines projecting from the curve display the magnitude and direction of the curvature at that point, and can be used to locate irregularities, inflection points, and sharp corners. You can change the comb scale and density within the dialog box. The curvature comb can also be displayed outside of the Edit Spline dialog by choosing the toggle under Analysis, Curve, Combs. From this menu, you may also change the comb display options. Several constraint options are available when moving a pole. The default, On Curve plane, places no constraint on the pole's movements. However, you may choose to constrain the slope or curvature at the spline's endpoint. You can also choose to constrain the pole's movement along a vector direction or on a plane. These options are not available until you have defined a drag direction or drag plane by using the datum axis or datum plane constructors. In addition, you may also constrain the pole to move in the current viewing plane. Also, if no directional constraint is applied, you can constrain the pole to move only in the horizontal and vertical directions by dragging the pole with the cursor while holding the Shift button on your keyboard. A few more options are available back at the Edit Spline dialog box. For example, Move Multiple Points allows you to move a segment of spline without affecting the rest of the curve. To use this command, you must first specify the endpoints of the segment of the curve which you wish to move. All other points outside of this segment will remain stationary. Then you are prompted to select the first point within this segment from which to define the distance and direction of movement. You can define this movement in 3 ways. The first option is to define a distance normal to the curve. This option automatically calculates the direction of movement, and you must simply specify the distance. You may also choose a vector defining the direction and specify the distance, or simply choose a destination point to which the selected point will be moved. You must then specify the movement of a second point along the curve and define its movement as well in order to complete the command. The Fit and Smooth commands can also be accessed in the Edit Spline menu. Fit will reduce the data required to define a spline by fitting it to existing points without changing the shape of the spline. Smooth will reduce variations in the curvature distribution of the spline. This command will increase the number of poles dramatically, and so should be done last in order to avoid complicated editing. The final option is to restore defining data for a selected spline which has been lost due to operations performed while editing poles.